All right, this video is going to be a video to help some of the harder questions on the Inventor practice exam 2 here. This is going to be a rough video because I left my list at home of the top misanswered questions. So I'm going to have to scout through them. I know the first two, 7 and 8, but I forget the rest. So you'll see me clicking through and wasting a little bit of time. Feel free to skip parts of the video where I waste that time. I am not going to cut it down. I am not going to edit it. I don't have enough time for that. I'm doing this on the weekend. You get what you get. All right. So let's go ahead and go into training mode for practice exam 2. Actually, you know what? If I resume test, maybe I can see which ones. No, I don't think that's going to work either, but it doesn't matter. All right. I'll know which one I left off on because it should bring me back there, which is 21. So that's somewhat helpful. But yeah, either way, I know I'm going back to question 7, which was revolve. So, oh no, there must have been one before this with the, it's 3. Must be 3, right? Oh goodness. No. Okay. Well, off to a good start. It's not 6. No. Okay. So we're starting with 7. And this question asks us to do a revolve. The question name was revolve, but it doesn't specify that it's a revolve in the question. So anyway, let's just get into it. So we're going to start a new Inventor file here. So a new IPT. So we're just going to do new part IPT. Wait for that to load. And we'll start a new sketch on the ground plane here, right? From the top down. It asks us to create a circular part, a cylinder. Why they don't just call it a cylinder, I don't know. But 6 inches in diameter and 4 inches thick, putting it on the origin. That part's actually important. Put it on the origin. Definitely make your life easier. 6. Finish sketch. Home view. Extrude it. 4 inches thick. All right. That doesn't look right at all. What did I do? Edit feature. There we go. Okay, so we have our 4-inch tall, 6-inch radius cylinder, and it asks us to cut an O-ring groove. So this is where most people got thrown off. They're like, what is an O-ring groove? It's not a thing you do in Inventor. It's just, they just want you to cut this little channel out of here. And if this was like a cylinder head on an engine, that would be called an O-ring groove because it's where a little rubber O-ring goes. Don't get thrown off by certain vocabulary on the test. Look at the picture, see if you can recreate it, and follow all the dimensions. And if not, that's okay, bookmark it and move on. But we're cutting a groove 0.25, 0.25, 0.25 from the top of the part, meaning when we're looking at this from the front, right, we're just cutting a 0.25 square, 0.25 from the top. That's it. Very simple. 0.25 on each side. .25 from the top. Why I put a 0 on that one, not the others, I don't know. But anyway, that's what we're doing. Easy. So we're going to go ahead and start a sketch. And we're going to start our sketch on the origin. So opening up the origin tab so that we can do it on the plane that's cutting halfway through, right? Which is the XY plane. I'm going to project geometry so I can get the top line here and the right line there. Okay. I'm also going to slice the graphics right there. F7 also at the bottom of the screen. That way I can see halfway through this cylinder where my plane is drawing on. You see that? That's all that does. But it's very helpful because The rest of the cylinder was blocking my view of where I'm trying to draw. I'm going to create a rectangle. It is 0.25 tab 0.25. So a square, right? And this square, as I said, is going to go 0.25 inches from the top of the rectangle. 0.25. And its right edge will be collinear with the right edge of the rectangle. Okay? Select, oops. Select collinear with the right edge of the cylinder. So it snaps. All right, 0.25 square, 0.25 from the rectangle, and it is resting 0.25 from the cylinder, and it's resting on the side of that cylinder. Finish the sketch and revolve this around. The profile that we're going to revolve is going to be this square. The axis, and this is why we wanted to do it on the origin, because the axis is going to be the y-axis, the one that's cutting through the origin. And if we select cut, you'll see it'll cut that groove. We click OK. Now, my issue when I tried to do this was I thought I could just cut a circle, another smaller circle, and cut it 0.25 down. For some reason, the answer is slightly different. I don't know why. And I'm not too concerned with why, because the good thing about the test that Autodesk makes is they're going to be really clear. They would say if they want you to do a revolve, they're going to tell you that they want you to do a revolve. And if they want you to just sketch a smaller circle and bring that down, they'll tell you that they want you to do that. So that's the good news there, that they wouldn't be as ambiguous. Because if I were to do this, I would do it as a circle. I'm not going to show that in the video. But if you want me to show you in class, I guess I can do that. But anyway, what's the volume of the part, right? So right click part one, eye properties, physical, update. What's the volume? 111, 968. Do the old copy paste. And click next. Yay. Okay. The next one that people asked me, or that people were getting wrong, was the one where we were trying to look at the line, the center line, which is why I thought it was 3. But goodness. What was it? Parameters I thought was 1, no? Oh man, this video is going to be a mess. Okay. Dimension types, sketch constraints, shell? It's not 1. Another parameters question. Is that one of them? Nope. That was the same one I clicked on last time. All right. Yeah, boy. All right, I'm just going to have to go in through because it's the only way I'm going to figure this out. Wasn't that one? Wasn't that one? Here we go. Canard. So here it asks us to create a section view 10 inches from the center line. So let's open up Canard. Right, close. We'll close part 1. We'll open geometrics templates, which is in my documents. Canard. Now, notice that we're opening the drawing, not the part. So we're going to open the one that says DWG, not IPT. Wait for that to load. Okay. Wonderful. All right. So they did a cut here at A, but that's 20 inches away. See? They want us to do one that's 10 inches away. And unfortunately, you can't just go ahead and smack a section line here like that. Right? You can't just do that. It's not going to work. Can't just click on this. It won't let you. So we have to have something to reference. So this center line is what we're going to do. Now, the main reason people were getting this wrong was because they knew that they had to go into a sketch to get a line that was 10 inches away, but they went over to this sketch tab here and started a new sketch. But in place views, you need to click Start Sketch. And the reason why is you could think of this sketch as placing some tracing paper over your drawing and then drawing on it. You can't click on other things if you do that. This sketch is drawing literally right on the paper, so we can click on things, right? And that's exactly what we're going to want to do. So how are we going to do that? We're going to go ahead and create a line at the very same point here where the center line is. So from top to the bottom, all the way down, a line. Okay. Then we're going to offset that line. Okay. "10 inches to the right." Then we're going to delete the offset. Now the line's going to turn purple because it's unconstrained. It's not constrained, but it doesn't matter. It's still 10 inches to the right. And if you wanted to double check that, right, we could dimension this to the center point there, 10 inches. There you go. It's still unconstrained because it could still be, taller, but it doesn't matter. We've done what we want to do. So we can click Finish Sketch here. And now we can use this line to create our section. So we click on it and we pull it to the right. And it doesn't matter how far we pull it to the right. It could be here, it could be here, it could be here. It doesn't matter. We just need to drop it somewhere. Okay. Now we can zoom in and we can annotate a dimension for what they're asking for on the geometrics test, which was just the top of this big curved line. See this like blue line here to this point here at the bottom where it touches. Pull that over and it's 16.60. If I go into geometrics, hopefully, when I type in 16.60, we click next and get correct. Okay. So the drawing questions can be tough. I'm not going to lie, especially cut sections, because the section tool is just so finicky, because you would think you could just go in here, right, place the section view down, from here to here or whatever. And then like press enter to go to the next part of the section tool, but you can't do that. It won't let you, doesn't know, like it's such a finicky tool. So, yeah. All right, great. Let's go on. I'm gonna have to keep clicking next to go through this until I see one that I remember. Yeah, I remember that one. Skipping. Some people struggled with that last one, but I'm not too worried about it. Concentric. I hope everybody knows how to do that. Shell questions are pretty easy. Okay, here we go. We're creating a rod that's 0.25 in diameter between the two indicated surfaces. So with that, this is create.aim or IAM. Slightly dyslexic sometimes. I also have a terrible memory. What was it? Create. I knew it started with a C. Okay, now I'm totally losing it. Context create. Holy moly. Okay. Context create. There you are. Open. So we need to create a rod that's going to connect between these two surfaces, right? Boom, boom. So what we can do is on one surface, we can create a sketch, right? So what we'll do is we could just create a new component. I think it asks you to name that component something like rod, which, I mean, I guess it'll make it easier for us to find, right? And we can click on that surface. When we start our sketch, we're going to start our sketch on that surface. Zoom in. Okay. It doesn't have to be perfectly aligned with this hole, but I mean, I guess we could do that, right? Boom. Look at that. All I did there was project geometry of that hole. Now they're centered. Not that it really matters. 0.25 diameter rod. So I did a 0.25 diameter circle. Click OK. Extrude that. Be careful if you do that, because look what happened. It wanted to make a hollow circle. Let me show that one more time. Here. Right. When I clicked on that, that's not what it wanted, right? So you have to click on both so you get the whole thing. And now we want to go all the way to, right? This has to extend all the way to. So we're not actually typing a distance, we're going to. So we're going to press the 2 button there. The other side. Clicking on that face. It'll tell you that exact distance right here, but I'm not so concerned about that, because all I want to know is that it's going from one spot to another. Click OK. Right click on the rod, get its properties so that we can find out its volume. Wonderful. 0.242. Next. Correct. Beautiful. Alrighty. Close that. Close that. No. Oh, this was definitely one of them. Cycle gears. Cycle gears is an assembly question. I guess that last one was kind of technically an assembly question, but not really. That could have been a body as opposed to multiple parts. But anyway, this one is a true assembly question, because here we're applying constraints, and boy, can they be annoying. Now, the first thing it asks us is to join this face of this rod here, right? The part that goes all the way around to the circle there, to the back of this. Ooh boy. To the back of the sprocket here, right? It's like a bicycle gear sprocket. So your natural tendency might be to click on that face, but we're not going to do that. Much more accurate is to click on the ring. You see this ring? If we click on the ring, it's going to line those two holes up perfectly. And because this ring is cut out to accommodate where that key is going to go later, that little rectangular piece of metal, it'll also line that up, because see, there's an indent for it over here. So if we connect that ring to this ring, click OK, and we flip over to the other side, you'll see it lined those up for us. See that? Super helpful. That part's easy. All right. This part's a little harder. Notice that metal part that's going to go in there. This little metal rectangle. It's got a fillet on it. You see that? So it's got that curve. If we zoom out, we go back in to that part I was zooming in on before. We'll notice if we start turning this, it's got the opposite of that fillet curving up and over like that. So we want those two parts to match. So remember, we're going to not click on faces, and instead we're looking for like lines to click on. So knowing that I want the curve where that curve is, on the opposite end of that curve, I can select the line. So when I constrain this, and I can click on this back part here, and that's going to be on the back inside line here, the opposite of where the curve is. There's the curve. There's the back inside line. I click on that and it's in its spot, right? Now, I'm going to click OK. And it looks like I just so happened to get lucky there that lined up perfectly. Because usually what happens... Oh, it didn't line up perfectly. All right, very good. If I look at it from the top view and I zoom in, look what happened. It went into its spot, but it's not over all the way. Now, you can do multiple rigid constraints, right? They were called rigid in Fusion 360. These are called... what type is this? I guess it's just called a mate, right? So you can do multiple rigid or mating constraints as long as the piece would be able to still move to that position, right? So let's look at it this way. Let me click that and then move back. So this metal rectangle here was mated to that back line, like somewhere like roughly over there. But it could still, it could still move up and down like that, right? We can move this up and down, which is why we have this gap. So we couldn't do another mate for the front of this somewhere else, because if it's mated to the red line in the back there, it has to be mated to here. We can no longer move this piece in this direction. We can no longer move it horizontally because we've already mated it to the back here. But we can move this piece up and down vertically. It's just like when you constrain a line, right? You have to constrain it in multiple ways. So when we do this mate, what we're going to have to do is say that I want this face now, and now we can do a face, to line up with the face on the inside. It's got to, I want it to touch this. When I click OK, now this thing is seated perfectly where it's meant to be. It's perfectly in that slot. And now I can get the z-axis of the center of gravity. Always remember when you're getting like center of gravity for an assembly that we're getting the eye properties of the entire assembly, not one of its parts. So let's go over to eye properties for that. Let's go to physical, update, z-axis, 12445 C, control C. That's why I said the word C there, not just randomly shouting letters. Okay, correct. All right. We didn't do that one. All right. Last one that we did was this one in class. We did the barrel, which is, you know, very interesting that they're, well, I guess this test is meant for adults, so it's still interesting that they're teaching you to make gun barrels in Fusion 360, right? I just said the word gun, so I guess this video is demonetized. Not that it was monetized in the first place. All right. Wow. Let's focus. Open barrel.ipt. Open. Number one, place a through countersunk hole centered on the face labeled 1. So that's going to be, when we click right, it's we're going to actually make this into a gun barrel, right? Right down the middle of this. So we're going to click on hole, click on this. We're going to center this. All right. So let's click on that, that there. I don't know why I have 2 holes now, but hopefully that figures itself out. It wants us to use a countersunk hole where the countersink diameter is 15 millimeters. So the countersink diameter is the widest part, because you can see the diagram of what a countersunk hole is, right? It's meant to, in this, oh, okay. I'm not going to talk about why it is on a gun, but usually we use countersunk holes for screws, because this screw part of the head is wider than the rest of the screw, of course. And we countersink it so that the screw head doesn't sit like above the wood or the metal or whatever. It's when you rub your fingers across the surface, the top of that, the head part of that screw is under the wood, so it doesn't catch on stuff, right? So when they say countersink diameter, I'm talking about the widest part there. Excuse me. So there we have 15, right? Yeah, this is making 2 holes. Why? 2 positions. 9. 1 position, please. Oh boy. There we go. I guess I had to click and drag. Countersink angles 90 degrees. That's the angle here. That's default. Clearance diameter is the diameter of the shaft. That was called shaft diameter in Fusion 360. Right? You can tell Fusion 360 tried to clear up a lot of the rest of this this language here. Termination just means where it ends. Termination is going to be through all, going all the way through. So we can end that hole. We're done. Next was a simple drilled hole from edges 2 to 3. From edges 2 to 3. So that just means that we're going to put one here. So let's go from, not from right, but let's flip this over to front. Look at this part here. This is like the iron sights of this barrel. We're going to create a hole on that. It is going to be a simple hole. Is it going to be counterbored? No. So no seat either, looks like. Its depth is going to be 5 millimeters. So this is not through all anymore. Its termination is going to be a distance. Its depth is 5. Its diameter is 2. That's that one there. The angle drill will be at a point. Right? It doesn't say the angle of it, so we're going to leave it at 118. It's going to go from edge to 10 millimeters, which is the front, and edge 3, which is the top, or I guess for my case it would be the right, and 2 is the bottom. 10 and 5. So we're going to pick positions. The bottom was 10. I did not mean to end that hole. Edit feature. And its next position was the top here, which was 5. Okay. We have 2 numbers like that, it's going to be able to give it a locked in position of where it's meant to go. That's the end of that hole. So I can click OK. Now why that wasn't through all, I don't know, because it just goes through all anyway, but not going to question the fine people at Geometrics. We're going to go and click on this part now and create a hole here. This is a counter bore hole. So counter bore is like countersink, except it's flat instead of at an angle. The counter bore depth. So it's the depth of this square part is 2. It's already done for us. Its counter bore diameter is 10 millimeters. Depth is 2, which was already done. Its clearance diameter is 5. Clearance being the shaft of the hole. And its termination will be through all. And both of these holes are concentric with the radius corners. So when I go to put this thing on there, right, I'm going to make sure that it's in there. I click on the radius and it's concentric with that. So when I click OK, I can do all I have to do, it remembers all of the numbers from the last one you did. So I'm just going to click there and click there. And now I'm done. Those two holes are very fast. And if I did all that correctly, I'm rushing now because I want to get this done with. But if I did all that correctly, I should be able to right click on here, go to write properties, eye properties, and find the mass of the barrel this time, not the volume. The mass is 3.978. Come on, 8. Copy. Paste. Next. Correct. So there you go. I hope that helped. As always, I hope that was helpful. Hope that we're studying and getting close to being able to take this test. I'll see you in the next video.